Sometimes the most common objects are the most fascinating. Take a simple torch, for example. Today, we're going to pull it apart, not literally, of course, to see what makes it tick. We're talking about that invisible force, electricity.
So seriously, how does it work? I mean, it feels a little bit like magic, right? You just flick a switch and boom, you've got light. But what is actually going on inside that plastic case to make that happen?
All right, to get to the bottom of this, we're going to break it down into 5 main parts. We'll start with where the juice comes from, and we'll end up looking at the very materials that make the whole thing possible.
Now, most of the time, when you think about electricity, you're probably picturing massive power stations and those huge transmission lines, right? But what's so cool about a torch is that it's all right here. It's like a tiny, self-contained power plant you can just stick in your pocket. And that makes it the perfect thing to study to really get the basics.
Okay, so first things first. Where's the power coming from? Well, obviously it's not from a wall socket. The real heart of the torch is the electric cell, which, let's be honest, we all just call a battery.
Go grab any battery. Seriously, take a close look. You'll see it always has 2 specific spots to connect to. We call these terminals. There's the positive side, which is usually that little metal cap with a plus sign, and then the negative side, that flat metal disc with a minus sign. And believe me, this 2-sided design is absolutely critical.
So a good way to think about it is that the cell is basically a miniature power plant. It's packed with chemicals, and it's doing this amazing job of converting that stored chemical energy into electrical energy. But, just like the gas in a car, once those chemicals are all used up, the power's gone. That's when you know it's time for a new battery.
Okay, so we've got our power source, awesome. But a battery just sitting next to a light bulb, well, that's not going to do a thing. We actually have to build a path, a sort of roadway for the electricity to travel from that battery all the way to the bulb.
And hey, check it out. Just like the battery, the light bulb also has 2 terminals. Now, the real magic happens inside that little glass bulb. You see that super thin wire in there? That's called the filament. Our whole goal here is to get electricity to flow right through that tiny wire. Once we do that, it'll heat up and start to glow.
But what happens if we don't connect it right? Like, what if we only use one wire? Or what if we connect both wires to the same side of the battery? Well, you get nothing. The path is broken. The filament stays cold, and yep, you're still sitting in the dark.
Okay, but this is the real aha moment. Look what happens when we create a complete unbroken path. We connect a wire from one terminal through the bulb and then all the way back to the other terminal. We've made a full circle, a closed loop. And bam, just like that, it glows. We have light. Now, this complete path, this closed loop, it has a special name. And honestly, it's the most important idea we're going to talk about. It's called an electric circuit. Just think of it like a racetrack or a highway for electricity. The current flows out of the cell, zips through the bulb to light it up, and then races right back home to the other terminal.
And here's the catch. That path has to be perfect. It has to be completely unbroken. If there's a gap anywhere, maybe a wire comes loose, or if the tiny filament inside the bulb snaps, which is what we call a fused bulb, then the circuit is broken. The flow of electricity just stops dead in its tracks, and the light goes out.
So how do we control all this? I mean, you can't be messing around with connecting and disconnecting wires every single time you want to turn on a light, right? Of course not. That's where the switch comes in. The switch is basically the gatekeeper for our electrical highway. When you have the switch in the off position, what it's really doing is creating a gap in the circuit on purpose. It's like raising a drawbridge on that highway we talked about. The path is broken. We call that an open circuit, and no current can get across. But then you flick that switch to on. And what happens? It closes that gap. It literally lowers the drawbridge. Now the path is complete. The circuit is closed, and the current can flow right through, lighting up the bulb.
And really, that's all a switch is. It's just a simple little device that's designed to do one thing and one thing only, to either break the circuit or to complete it, to turn it off or turn it on.
All right, let's get to the final piece of this puzzle. We know we need a path for the circuit, but what is that path actually made of? I mean, can you use just any material to carry electricity?
Well, as it turns out, the answer is a big no. If we try to complete our circuit with something like a metal key or a paper clip, yep, the bulb glows. But if you try the same thing with, say, a rubber eraser or a plastic scale, nothing, not a flicker.
And there's a reason for that.
Materials that allow electric current to pass through them really easily are called conductors. Things like copper, aluminum, pretty much all metals, they're fantastic conductors. And that's exactly why the wires in your house and in this torch are made of metal.
Then you have the opposite. Materials that do not let electric current pass through them are called insulators. Rubber and plastic are great examples, and so is the air all around us. This is why electrical wires are always coated in that plastic stuff. It acts as an insulator to keep the electricity safely inside the wire, right where it's supposed to be.
So you see, it's not that one is good and one is bad. Conductors and insulators are equally important. You absolutely need both. You need the conductors to make the path for the electricity, and you need the insulators to keep that electricity contained and to keep us safe.
So let's put it all together now. When you look at a simple torch, you're actually seeing all these key ideas in action. You've got the power source, the electric cell. You have the path, that's the electric circuit made of conductors. You have the controller, the switch, and you have the safety material, the insulator, which is usually the plastic case you're holding.
And this brings us to one last really important thought. This stuff isn't just a cool science lesson. Here's the thing. Your body is also a conductor of electricity. So understanding what makes a circuit complete, well, that's not just about making a torch glow. It's absolutely crucial for knowing how to stay safe around any kind of electricity.